Hello guys, I'm going to go over the material that we discussed last class about parallel and series circuits, and I'm not going to go into details of what I already discussed. I'm just going to give you the circuits for each and then write down the equations, and then I am going to do an example for the quiz. Okay, so this is a circuit and the resistors R1, R2 and R3, they are in parallel to each other, and there you have the current, and the current is going around the circuit. Same current passes through each resistor, and therefore that is actually a characteristic of the parallel circuits, right? So here we have the battery. This is the symbol of the battery, and then the voltage, if you like, you can mark it like that. And as I said, first thing that you do is draw the equivalent resistor here, and you call it R equivalent, and the rest of the circuit should be the same, and the current that I marked over here, I, it should be the same I. Now R equivalent equals to R1 plus R2 plus R3, and that is the characteristic of a circuit with with resistors that are in series. And also, if I mark the voltage drop across each of these resistors, I am going to call it V1 over here, V2 and V3. So I am using different colors so that you can see them better. And the main circuit or the battery has a voltage of V, and that V equals to V1 plus V2 plus V3. And the V1, V2, V3, those are voltage drops across each resistor. And then in both circuits we can use V equals to IR. So in order to find the current I, we can use V equals to, let me actually use the same color coding, I, and then instead of writing R, here we can write R equivalent. And then R equivalent is given from this equation, or given by this equation, and you can substitute it in there and you can find what I is, assuming that you know what V and all the resistors in the circuit. So you can get I in this form. So that is basically the series circuit. Now I am going to draw the same for do the same for the parallel circuit, a simple circuit. And let me draw that, and let me call the same R values here, R1 and R2, R3. These are the resistors. I'm going to complete the circuit, and I am going to use a different color. You know what, I am actually going to use the same color for the main circuit I, and I am going to split the current on each branch, at each branch. So this is a branch, and there is another branch, and there you can take this current as I2, and let me actually use another pen. So there you have I3. And we discussed that I3 is coming this way, and I1 is coming to this junction, and I2, and there you have I2 plus I3 going through this branch. And when you get to this point, the I1 coming from above joins, and there you have I1 plus I2 plus I3, and this is what we called as the junction rule in the class, right? So basically in this section, in parallel circuits, your main circuit I equals to the sum of I1, I2 and I3. That is one of the characteristics on a parallel circuit. So let me actually write it down here, parallel resistors. Now we do the same thing as before. We get rid of all these resistors R1 and R2 and R3, and we get the R equivalent here. And then the voltage is like that, just like before, and the main circuit current is like that, and the main circuit current goes around. Now in this case, our equivalent is given by the following equation. We don't really call it by as R equivalent directly. We write it as 1 over R equivalent and 1 over R1 plus 1 over R2 plus 1 over R3. Now if you know the R1, R2, R3, you can substitute the values in here, and then you can add those things together, and you can get the reciprocal to find R equivalent. But as we did in the class, if you don't know what R1, R2, R3, this is the general equation. I showed all the steps in the class, so I'm not going to do that because I don't want to make this video too long. And this is what you will get: R2 R3 plus R1 R3 and then R1 R2. So this is the equation for R equivalent when you have the resistors in parallel. Now this is not an equation that you have to memorize. Actually you should not memorize this equation. If you want to memorize something, then this is the equation that you should memorize. Now when you have more resistors in reciprocal form adds up. So this is the form that you need to remember or understand. And then the same Ohm's law equation comes in, and we can use V equals to IR, that is the Ohm's law. And then we can use V equals the main circuit current is I, and the resistor we are using R equivalent. Now since we know R equivalent from the equation that I boxed in red, you can find I equals to I equals V divided by R equivalent, and using this you can find the current in the main circuit. And then after that we discussed the power. So the power was given in mainly using one equation. Then I showed that using Ohm's law we can look at different forms. So the equation that we looked at for power, the first one is P equals V times I. V is the voltage drop or the voltage difference. And when you use Ohm's law and substitute for V by IR, then you have the equation in this form. So you have P equals I square R. So the first one is this, and this is just a derivation of that. And if you replace I by V over R, then you get P equals V times V over R. If you replace I, then you get P equals V square over R. That is again another form or like another way of writing power. So power also, the power equation also was used in the circuit. If you want to find the power across a resistor, then you can find the voltage across that resistor, and if you know R of the resistor, then you can use the equation, the last equation, to find the power on that circuit. Let's say you know the voltage across the resistor and the current across the resistor I, then you can use the first equation to find the power. And the last one, let's say that you know the I and the value of R, then of course you can use the second equation to find the power. So that is how it works, and the power across each resistor adds up into the power of the main circuit. And we looked at some of the problems in that section as well. Now at this point, okay, I have spent almost like 10 minutes. I'm not going to do the same problem that we discussed in the class. But I am going to do slightly a different problem, but the same exact steps that you need to follow. Okay, so here I have an example, and I can actually go faster. You can stop the video and check things out. Now the example has two resistors that are in parallel. Okay, like that, the two resistors are in parallel and one resistor is in series to the parallel setup, something like that. Let's say that the first one is R1 equals to 10 ohms and R2 equals to 20 ohms and R3 equals to, let's say, 5 ohms, and then the voltage across the circuit, let's say this equals to 3 volts. Okay, so that's what we have, and we are supposed to find the equivalent resistance for this circuit. So let me actually write that down. Find equivalent resistance for the circuit, and the second one, find the total current in the circuit, and then the last part, find the power across the power source. The source means the battery, right? So we have three problems to deal with, and let's look at how to find the answers to this problem. Now, as I discussed in the class, the first things first, we have a place where you have two resistors in parallel. So you mark that area and you are going to find the equivalent of R1 and R2. And the equivalent of R1 and R2, I can call it R12. And since they are in parallel, this is the step that I follow. 1 over R12 equals 1 over R1 plus 1 over R2. I use the word equivalent since it is not the equivalent of the entire circuit. I am giving this special name, the equivalent of R1 and 2, right? So I am going to substitute R12 equals 1 over 10 plus 1 over 20. So here we have fraction addition. 1 over R12 equals, the common denominator is 20. So you are doing some math here and you get 3 divided by 20. Take the reciprocal to find R12, and that's going to be 20 divided by 3 ohms. Now that we have the equivalent of the R1 and 2, I am going to use that and redraw the circuit. So when I redraw the circuit, I am not going to draw the parallel setup. Instead, I am going to call that parallel arrangement the two parallel resistors by R1 and R12, and the rest of the circuit goes as normal. So here you have R3 and the source has a power voltage of 3 volts, and that's that. Now again, I am following the same steps that we discussed earlier. Here we find two resistors that are in series. Now what I do is I am going to get the equivalent of those two, and I am going to call it R1, 2, 3. Okay, so here we have the source, and let's substitute the values. Now to find the R1, 2, 3, R1, 2, 3, we are simply adding those because the two resistors are in series, right? So the R1, 2, we found it as 20 over 3 plus R3. Let's go back and find R3 is 5. So you can find what the value for these two is. So yeah, so I found what the sum is 20 divided by 3 plus 5, and you get R123 equals to 11.67. So the first question, find equivalent resistance, and we are done with that, and we can circle it. This is the equivalent resistor of the entire circuit. So you can stop the video or rewind the video and go back and see what we did. And the second question is find the total current in the circuit. Now in order to find the total current, part B, we are using V equals IR. Now V is the source voltage, 3 volts. I is what you are looking for. R is the R equivalent, which is 11.67. It is in ohms. So when you take everything to one side, you get 3 divided by 11.67, and that's the current. 0.257 in amperes, and that is the second part of the question. And then the last question is finding the power across the source. Now the source is the battery, and if I go here and mark the battery voltage, V equals to 3 volt, and at this point I know what the current is. Current is 0.257. I can use the first equation that we discussed for power. Power equals V times I. Now V is 3 and I is 0.257 amperes, and the answer is, and the SI unit for this is 0.77 watt, and that is the answer to the last part. So here you can see that a problem that we discussed, a good problem, I mean more or less like an exam type you can say if you want to, and don't forget the units. And you can see how I broke down the circuit by looking at each section. Okay, so go over this, and we'll meet in the next class.